Hello everyone, and welcome to today's webinar, On-Site Prefab Wall Installation Evaluation. My name's Ricky Cartwright and I'll be your administrator for today. So this is the final webinar in our series as we're counting down to Digital Construction Week, which is actually starting tomorrow. So me and James, who's also going to be presenting today, will be live at Digital Construction Week tomorrow and Thursday. So if anyone else is attending and wants to meet up to discuss more about the things that we're showing today or anything else, we'd love to meet up with you and talk construction. So for today though, we've got the webinar ready to start in a few minutes. The two hosts we have for you today are James Brown, who's the head of digital manufacturing at Protex, and James has a wealth of experience in production and delivering digital manufacturing solutions for construction. And we also have Mary Samuel, who's a digital manufacturing engineer at Protex, and she's been working with James to deliver digital production simulations for our construction customers. And she's going to be sharing some of her know-how and techniques with you guys on that. But before we kick off, there was just one more thing I wanted to mention, and that was that we're going to have a question and answer slot at the end of the webinar. So if you've got any questions throughout the session, you should have a little question box on your interface. So if you type in any questions into there, I'll collate them all and then I'll put them to James and Mary at the end of the session. So that's it from me. Thanks for your time, and I'll hand over to James now, and we can get started with the main content. If you're ready, James, let me just share the screen with you.
Cool, thank you very much.
If I can change presenting, sorry, here you go. There you are, you should have control now, James.
Cool, thank you. Let's see if I can share my screen. It's always a good start. Cool, nice. So yeah, hopefully you can see that. So thank you again for joining us today for the final session, as Ricky said. Hope you've enjoyed all of them, and I'm sure you'll enjoy this one as well. So today me and Mary are going to talk to you about on-site prefab wall installation. So before we dive into that specifically, so for those of you who don't know us, so Protex is based in Euro North. So we have teams based in Sweden who specialize in automotive, teams based in Norway who focus on infrastructure, mainly bridges and heavy steel work. And then for us in the UK, our primary focus is a mixture of aerospace and of course construction, hence today's webinar. So the core of our business is kind of 3D experience and primarily DELMIA, all focused around digital manufacturing. So I always like to pitch us as we're a company of manufacturing nerds who love doing software and love doing solutions like this. And we also offer training, licenses, and expert consultancy in that as well. So if you like what you see today, please get in touch. And then I always just like to mention this too, that we work in both robotics and tooling design, not to plug that, but just to say, basically we're not just software people, we do real manufacturing as well. So we go through a lot of the same problems a lot of you on the call are going through. We see a lot of safety issues in the field, process issues, so we can relate to it because we've been there as well. So if you've missed the rest of our webinars, I'd really encourage you to go back and register and have a look at them. This is the 7th in a series that we've been doing, and then we also, as Ricky said, are at Digital Construction Week tomorrow and Thursday as well, so come see us there. And then again, one last thing before we kick off, I guess, is for those of you who've never heard of 3D Experience, if this is your first time listening to one of our webinars, I just kind of want to introduce what this software is that we're talking about in today's session. So this is all about bringing data together into one place. So this is, when I say data, I'm talking 2D, 3D, building data, tooling data, people, ergonomics, changes, issues, project management, tasks, sales, marketing, you name it. It's bringing all that data into one place. The second big thing is data's meaningless without people. So it's bringing all the people that would usually handle that data into one area as well. And then the third big key thing is it's about giving those people the tools to enable them to use that data to give them creativity to produce awesome stuff like Mary has for the session today. And just to, again, touch on it, but the really key thing for this is it's all about data-driven decisions and data-driven user experience. So this isn't just fancy animations, this is real tool data, real ergonomic data, real crane data driving all of the simulations here. And cool, and before I just hand over to Mary to do the initial talk through, so what are we actually going to talk in this webinar? That's why we're all here. So in today's session, we're going to evaluate a on-site installation of a prefab wall. So if you've missed it, in the past 2 webinars, we simulated a traditional stick-built architectural wall in the field, and we figured there might be a better way to do this. So in the last webinar, we looked at could we actually make this in a microfactory? And then in today's session, we're going to look at, okay, we could make it, and we think we can be more efficient in a microfactory, but what impact does that actually have to the site? Have we increased the time on site? Have we increased the resources or increased the skill level? So we're going to assess that. We're also going to look at the on-site logistics, and then just compare, to finish off, we'll compare this back to our original traditional stick-built wall as well. So yeah, so buckle in, should be an interesting session. Yeah, so I'll hand over to Mary.
Thank you, James, for the introduction. So we move on to manufacturing bill of materials, also called as MBOM. So we're looking into scenarios, just like James mentioned earlier. One is for the traditional wall, and the other one being for a prefab wall. So on top, on the traditional wall, you can see that it's got 5 steps. So it looks very complicated. It's got lots of kits and sub-assemblies that will require a lot of resources to be shipped to the site. On the other hand, if you look at the prefab wall MBOM, it's very simple. It's got 2 steps, starting off with your wall being prefabbed at the microfactory, which goes to the site directly, and the last bits that go on to it is the final parts, as your end parts of the wall that gets shipped to the site. So there's very less resources being shipped to the site again, and it's quite simple compared to the traditional one. Moving on to the process engineering and 4D. Since the MBOM of the traditional site was traditional wall was quite complicated, so that led to a very heavy process. So now this means that it will require a higher process time. So the fact that being more complex will require all the workers being assigned to the site to have a specialization in this type of wall building. And if you compare that with your prefab wall, it's got only 4 steps, starting with your transportation, moving on to your lifting to the site, then the installation, and lastly with inspection. So it's quite easy to understand, and it's very easy to train someone who's new to doing the process. So this would require less process time, as you know, time is money. Okay, cool. Anyway, moving on to the next one is a site layout. So in the site layout, as you can see, there's a lot of resources in the traditional wall traditional wall process. So yeah, there's around 8 resources that I can see, 8 to 10 resources that I can see. So that looks like it's very congested. There's a lot of safety issues that will tend to pop up, and it looks very busy as a site. But if you look at the prefab down below, it's got only 4 resources. There is no issues of safety that I could see, and there'll be no waste bins, and there's less resources on the field because you'll be having only like final boards being added to the site. So that's the plus points about that. And lastly, if you go to the 4D site simulation equipment, this is a way to see how my resources are going to link to my process, and how I can visualize how everything moves around it. So starting off where we can see how the pallet moves to the particular pillar, and the wall gets lifted up. So if we did see that again, we can see that it hits the resources down below, and the fact that it shows clashes and tight spaces. So this is a way to identify how I can have different materials being transported to that specific route or material flow. Apart from that, it helps in easy communication, and lastly, it also helps us see how the workers will reach and access the panel installation using, and over here we're using a genie to help the worker move up, and we can quickly verify this through ergonomics, which I shall hand over to James.
Cool, thank you, Mary. And I think the big thing with this, just to touch on as well, is this whole idea of in construction, we see it's very common to simulate a process, and there's no people, there's no tools, there's equipment. This will just appear, and that's it. So what we're seeing in this is people, equipment, tools, where it's flowing, everything that's happening. So it starts to give you real points for discussion and communication with the team. So to give some real life experience from doing this on previous projects, we've simulated things, prefab products, numerous times where a customer has said to us, this is exactly how it's going to happen. We've simulated that, what they've said, and then we've shown them the simulation. They've said, one of them said, perfect, that's exactly what we meant. And the second one has said, that's not what I meant. And the third one has said, that's not what I meant either. And then there's been actually, they were all saying the same words, but they were all meaning something completely different. So through simulating the equipment and the people, we can actually make sure your teams are talking the same language, because how can you argue with real life 3D that's in front of you? Cool, and as Mary said, so Mary pointed out there is a potential worker safety issue. So we could see there's still a little bit of working at height during the simulation. So it's absolutely no problem. So this isn't a specialist whole other software. This is, we switch app, excuse me, we switch application to the ergonomics, and we start to evaluate if this thing is safe. So unfortunately, one of the biggest challenges in construction right now is still worker safety, to make sure people are not under huge strain, they're in a safe environment, and their safety has basically been considered during the process. So because we have that full, jump to slide, my bad. Because we have that full simulation, we're able to simulate every single step that worker is going to do, which means we can verify all of the extreme postures to see, can this worker actually lift that plasterboard on their own, or do we need two workers up there to make that a safer operation? Can they reach to get that drill in? And just as they're in their extreme position, how safe is that on the worker? What's the strain on the joint? So you can see these colored dots on the workers, and that's telling us through some ergonomic mathematics, through something called ruler or rapid upper limb assessment, if that position is good or bad, basically, for the worker. We can also simulate lots of different percentiles, so we can see different genders, heights, weights, because obviously every country has different sizes and averages, and even within your own teams you might have different sizes and averages. So making sure this isn't just safe for the tallest person to do that operation, but it also works for the smallest person as well. They can also get in there and access it and do the job. Cool, so that's worker safety. So we've checked this to make sure it's safe and happy, and we were able to communicate those issues. The second big thing, which for me is often something that's missed in new product evaluation, is the material flow. So we understand material flow of traditional because it's lifting pallets of raw material up to a floor or a location, and we've been doing that for decades and decades now. So that's well understood. There's still some optimizations to be made there. Again, check out our earlier webinar to see some optioneering on that. But for this prefab product, we need to really evaluate that, because the product is way bigger. Because there's no raw material, we've built this in the factory. The product is substantially larger than it would have been before of just raw pallets and raw sheet metal. So how does that work? So we've simulated the same three options here of a telehandler, a mobile crane, and a tower crane, the same as our traditional. We've seen the tower crane and the mobile crane work, but there's some drawbacks there. They're expensive. The tower crane is going to take that off the critical path, which is usually the most expensive lifting equipment you have. So maybe a mobile crane, but still quite expensive. Versus a telehandler is a lot cheaper, a lot more accessible, lower. There's more people that can operate them as well. But the issue being, if I play that simulation again on the top left, is you can see when this thing actually loads into that bay, it's tight. So, and the driver can't really see what they're doing. So again, looking at safety, on the top left two screens, you can see different views of different spotters in the driver. So there's a lot of blind spots in there. You can see it's actually clashing with the loading bay. So that says to me, even in a simulation, which is as good as you're ever going to get, the real life isn't going to be as perfect as a simulation. It's tight. So we need to probably increase the size of that loading bay. Cool. So there's some nice optioneering for material logistics, and this can go further as well. And like in the 4D Mary showed before, we also saw how it gets to the specific site location. And now we have our traditional versus our prefab. So we simulated the traditional earlier in the previous webinar, and we have our new prefab on the right. So the processes, as Mary said, just to kind of conclude it, are way simpler for the prefab. There's less happening in the field, which means in theory it's easier to train up our new workforce to do this. The resources are massively reduced, so the site is way cleaner, there's less congestion on site, and there's a lot less material movement, which is less time, saves money. Further to this, we've actually increased the lean opportunities massively, both in the field, because now there's less happening there, so we can focus on those operations to improve them, but actually, most importantly, by shifting that work to a micro factory or a factory, where it's really easy to implement some lean opportunities there. And of course, the same thing with the factory, increases our safety opportunities. And just to give some, like, this is a fake scenario, obviously, but to give some rough KPIs. So in this example, on the left, the traditional wall installation, we have around 400 fasteners alone for the plasterboard, where versus on the right, we only have to install 80. So we're talking about a quarter, less than a quarter of the processes that need to be done in the field now compared to before, which means in the site, you can deploy this quicker and quicker and quicker than versus the traditional. But here's some of you asking, what does that mean for my higher sequencing? So it's not always as simple as one product. Obviously here we've proven out one product, we've checked the ergonomics, we've checked the safety, but we still need to check the sequencing. So the rough process is on the bottom. We're going to install the panel, we're then going to install the lower board finishings, and then we're going to install the upper board finishings, and it's done. Nice, easy, simple process. But what does this mean for our crew layout? So there's a couple of things that we need to consider here. Is do we complete all of one task and then move on to the next, similar to how the simulation is shown here, when we install all the walls and then we install all the plasterboard on the lower level, and then we install all the upper board? Or do we chase the work where actually someone's going to install the wall, as they move on to the next one, there's a team following on from them to install the other plasterboard? There's a risk there that people could end up working on top of each other and sort of waiting for one another. Sorry, excuse me. Just take a little drink. Lose my voice on the last webinar, it's a good sign. And then there's other important optimizations we can make too, such as how are we actually going to build this thing out? So if any of you have done this before, you'll be looking at the layout of the simulation thinking, that's pretty bad. So these people are going to trap themselves at some point. They're going to end up locking themselves in a corner. The way we would do this, looking at the high level, is, well, actually, because we're moving massive products here, what we want to do is probably start in the bottom right-hand corner and work our way out. So we're working back to the loading bay. So by doing this, we start to find some tips and tricks that we can take forward with us, capture in the business, and take for when we deploy this for real on the next project. So yeah. And yeah, so in kind of conclusion, so through that very quick 15 minutes, what we've done is we've shown you how we've developed a process for a new product. So we've captured all the information from the experts of how we build this thing, and we've shown the simulation of the resources, the worker safety, and the logistics of how the product's going to get from the truck to the location. We've compared the original stick built to the new and kind of looked at some KPIs of the differences here. And obviously this is for a wall, but this could be for any construction product in the field. We've also evaluated the multi-product deployment across a whole site. So it's important to not just think of one product being deployed, but how would it be deployed if you installed 100 of them or 200 or 300? And then we've captured some know-how as well. So all of this knowledge that we've captured, it's all in simulations, it's all linked to the product development, it's all directly linked to the design of this product. So now if anyone has any questions about how do we install this, how do we reach up there, oh, well, we did a simulation on that. Let's look back and check it again. If someone has a new idea of why didn't you do X, Y, and Z? Why didn't you have a big manipulator to lift this panel in because it's going to be really heavy? Great idea. Let's simulate it. Let's think about it and model that and simulate it and add it to our know-how. So we know when we deploy this for real on a new building, there's method A, there's method B, and there's method C. And these are the pros and cons of each. And this is the best one for that site. So it's going right back to what I said at the start. It's all about data, data-driven decisions, real data driving what products you're going to use, why you're going to use it, and also which method of installation you're going to use. It's no longer, which is a real anecdote from the field, let's do it this way. Why are we doing it that way? Because I'm the most senior and we've done it that way before. So there's real data behind why now, which is good. And yeah, so that kind of concludes the technical part of the webinar. So we've whizzed through it, hopefully not too quickly for everyone on the call. So if you've enjoyed that, as Ricky said at the start, please come find us tomorrow and Thursday at Digital Construction Week. So we'll be at the Dassault Systems booth if you want to come find us there. And I'll actually be giving a sneak extra talk / webinar also tomorrow, 11 or 11:30 on worker safety specifically as well. So if you're at Digital Construction Week, come find that. Should be fun. And if you want to get your hands dirty with this straight away, and you're thinking, ooh, can I afford it? So we have a promotion at the minute where we're offering all of the licenses you've seen to do everything today, plus all of the other webinars, plus a load more. And you can get a 3-month cloud-based trial for just £500. If you're interested in that, there's no commitment, just get in touch and we can help get you set up and obviously train you and things like that. And then if you want to purchase it after that, or if you want to skip the trial and just go straight to buying it and deploying it, or maybe you already have SolidWorks or CATIA and you want to delve into the world of DELMIA, we are a official reseller, so come get it off us. We can train you up, we can support you with the licenses and get you as skilled as I guess we are to do awesome stuff like Mary has for this webinar today. So yeah, please get in touch. And yeah, I can't believe it. We've finished this one on time. This might be the first webinar we've done that. But yeah, hopefully you found that interesting and it wasn't too fast. We've got, oh, there's some sound on that video. We have some time for questions as well, if anyone has any. Yeah, be great to take some questions.
Definitely. Yeah, thank you very much, guys, for talking us through that. I think that was a really good demo, and as I always say, I think it's better to be concise and ahead of time than going over time and keeping everyone waiting. So I think that's fantastic. We've got a few good questions here, but there's room for some more. If anyone has any extra they want to put to James and Mary to try and challenge them, feel free to type them in now. But I'll start off with a couple of the ones we've got here. So the first question here is asking, can the software tell me how much material a more traditional method will generate to compare it to my prefab installation?
Great question.
Yeah.
So yeah, exactly. So obviously through the simulation, what we're doing is we're through the NBOM stuff that Mary showed at the start, we're actually checking what kits of parts we need for traditional, and we're checking what kits of parts we need for the prefab. So even at the very first stage, we're straight away saying we need all of this material. We need plasterboard, we need studs, we need bracing, we need insulation, we need nails, we need different sizes, we need cutting tables. We need all of that stuff for traditional versus the prefab. We only need the wall, which is coming from a factory, and we need some plasterboard, which is pre-cut to size. So for us, that's showing the material actually in the field is way less. There's a lot less waste in the field because before you're taking all this raw material to site and you're cutting it in the site, you're having to install it. There's probably going to be some damage, some waste, things like that. So yeah, so kind of through that, we're reducing the material in the site, and we can see a direct comparison of before we had to take, I'm making this up now, but 10 meter lengths of studs to the field. With the prefab, we are taking some studs to the site, but they're cut to the exact length, already installed, already ready, so there's no waste there. Versus before, we take that massive length and we need to install it and remove the waste from the site too. So yeah, so hopefully that answers that question. So yeah.
One more question here is.
Oh, I think you might be on mute. Sorry.
Sorry, I muted myself there. Yeah, one more question I've got here, James and Mary, is can we use parametric models combined with simulations to speed up the process?
Great question. I don't know if you want to take that one, Mary, because you've dabbled with this quite a lot.
Oh yeah. Oh well, you can use parametric models as a template or instantiate it from your library or your catalog and insert it into your PPR. Well, yes, it does reduce your speed, and it helps create. What I mean, it's easier to generalize a template and then size it up according to what you like in your PPR. So yeah, does that answer your question? Yeah, it does speed up your process, definitely. It saves you time from creating it all from the start. Yeah.
Exactly. And just to add on that as well is so there's two different types of parametrics you can do for the field. So you can do parametrics for the product, which is where we start talking about config, like configured product design. So you're deploying that standard product template now for your specific site requirements. So that massively speeds this up. So we've seen this has been a massive trend in the construction sector right now. Some of the videos that is playing right now on screen. So you're seeing that with Bridge that our projects Norway team have done there of configured products. But this could be done for the wall here, where different heights could be deployed for different heights buildings or different lengths where it's required. And then there's actually the second, which is, I would say, the more well-known part of parametrics for construction. The lesser known is parametrics for resources. So, for example, Mary used a trolley to load this wall system into the building. If that trolley is designed a little bit cleverly, where it can be adjusted in length and adjusted in size, there's no reason we couldn't make that parametric as well. So suddenly all of our tooling and equipment for site is parametric also, making site layouts, simulations, everything way quicker. So yeah, hopefully that answers that.
Fantastic. Yep, great. And then one more that I think we've got time for one more probably, and that's what outputs can I get to do a time analysis, or is there something only the software can do? So I guess the question is essentially, can we get some outputs from the simulations you're doing to create some time analysis of how long these processes are going to take on site and build that into the overall plan, right, for comparison?
Great question. Yeah, definitely. So if you're really lucky from what we've seen in the past, if we're simulating this for a prefab product that's already been tested and already had maybe like an initial build, or it might have already been used on a previous site, and they're just trying to figure out if this will work for new sites in the future. We have historic data there. We have measured data, so we can use that measured time data in our simulations to check it for the next site and the next site and the next site. But exactly like I think this question is alluding to is you might not always have that, especially if this is a new product. It might be too expensive to build a physical demonstrator, or you're early in the R&D of this prefab product to go away and get funding to do that. So yeah, through the simulation, you could get times out. So for the workers, you could literally simulate someone reaching and doing something, and then we get the time output of how long it takes them to walk over somewhere, pick something up. Of course, this is just an estimate, a simulated time. You should always replace that with the measured when you have it. But yes, you could do that. Similarly for the equipment, like the telehandler, the mobile crane, the crane, if you have custom equipment as well, maybe for lifting and access, or like the genies, for those things, you normally have preset speeds, preset times, preset equipment mechanics, I guess. In which case, when we simulate that crane, it's giving me the real speeds. It's giving me the real time of how long this thing is going to take, how long the lift is going to take. So again, I'd always emphasize to customers, this is really handy if you want a rough order of magnitude of how long this process is going to take. And it can help you get in the ballpark region early on in the simulation, but that always needs validation. So you always need to check that against the real equipment you're going to use. Is the real equipment you're using slightly faster or slightly slower because of certain reasons? In which case, let's change our simulation times to match that. And we increase our know-how, increase our knowledge, and basically validate it. So yeah, hopefully answers that. Do you have any extra points, Mary? Or no? Cool.
Great, fantastic. Well, I think we're pretty much out of time there. So thank you so much, guys, for taking the time to put that demo together for everyone and for answering everyone's questions. And thank you, everyone, for attending and taking the time out of your day to listen in on our webinar. Hopefully, you all enjoyed it. If you did enjoy it, and you, as James mentioned, you want to access the previous webinars, I've put some contact details in the chat to let you know how you can request access to the replays of those. And if you have more questions about what you've seen today, please get in touch with myself, James, or Michael on the contact details on the screen. And with that, hopefully we'll see some of you tomorrow at Digital Construction Week. But yeah, thank you very much. I thoroughly enjoyed putting this webinar series together for everyone. So that's it. Thank you very much. Thanks for all your time, everyone.
Thanks, everyone. Thank you for listening.